I'm Didiakovas, the coordinator of the Thematic Strand of Risk and Safety in the Built and Natural Environments of the CERIS, which is a research unit in the civil engineering area. This thematic strand involves over 150 researchers and focuses on the assessment and management of the main risks associated with natural and man-made hazards affecting our built and natural environments. The risks are related with earthquakes, tsunamis, fires, floods, dam breaks, and landslides that can directly affect service buildings, monuments, bridges, industrial facilities, dams, and lifelines that provide essential services to our communities, such as electric power, transportation, water, and gas. Risks derived from poor urban planning and infrastructure degradation are also addressed herein. The thematic strand involves a broad variety of research studies that cross-cut several sustainable development objectives of the United Nations, in particular the Sustainable Cities and Communities and the climate action. Many of these research studies are based on extensive experimental programs carried out in the civil engineering labs, including full-scale tests such as fire tests of composite beams and small-scale tests, namely the study of local scour in bridge pillars and the flow dynamic in storage tanks. The research also includes field measurements in infrastructures such as seismic geophysical tests, water quality tests, and pipe transient tests in pumping and hydropower systems, and also advanced numerical modeling like the calculation of the temperature flux in composite beams, of moving loads on railway tracks, or the propagation of urban floods and tsunamis. This research strand aims to develop innovative approaches, tools and solutions to answer the future challenges of the society for a better assessment, mitigation and communication of the risks associated with the natural and man-made hazards. For this purpose, we have been developing reliable early warning systems for earthquakes, tsunamis and floods, and also reliable simulation of the catastrophic events and of training the first-line responders. Our research also aims to reach safer, better dynamic performance and lower maintenance infrastructures that go from buildings and bridges to water and wastewater systems. Additionally, this thematic strand focuses on a better planning of human activities and of resources location in order to reach more resilient communities in the built environment. Finally, we address issues related to transportation systems to respond to the current and future needs of the cities, namely to integrate future mobility solutions like electric bikes and self-driving vehicles, and to satisfy increasing transport demand, avoiding traffic jams, pollution and accidents. We have many research projects in our unit developed in these thematic strands. Thus, we have selected some related to this area to demonstrate what is done, attempting to cover different domains in the civil engineering, namely construction, structures, hydraulics, and transports. The first one is related to construction, and it is the full-scale experimental seismic and cyclic tests on a 3D frame of composite profiles. The development of sustainable and resilient cities and communities motivates the research for new construction materials that are structurally resistant, more durable, and with lower maintenance. These new materials should have adequate performance under natural hazards and extreme events. CERIS has been engaged in the development of corrosion-free structural systems using fiber-reinforced composites, studying and enhancing their behavior under extreme events, such as fires and seismic actions. The second project is related to tools for assessing and communicating the seismic effects. Many countries are exposed to multiple hazards. Very few natural events disrupt human society more than large earthquakes. Additionally, earthquakes are unpredictable, much more than other environmental events. Thus, being prepared is absolutely essential. This is precisely what we aim when modeling the impact of earthquakes and tsunamis, by assessing the risk and the danger and by improving seismic safety and performance of the built environment, especially in highly exposed areas. Improving resilience of the built environment to seismic shaking has motivated CERIS research on specialized construction materials and advanced engineering methods. Finally, creating awareness and educating people on how to behave during these events is absolutely fundamental for the society to adequately and safely respond to this natural hazard. The third case is modeling tsunami and urban floods propagation. Actually, numerical modeling tools developed at CERIS allow to more accurately study different risk scenarios related with natural hazards such as tsunamis and urban floods. Catastrophic tsunamis have affected the Portuguese coast numerous times over the past 2 millennia. The simulation of the effect of a tsunami, like the one that swept Lisbon off the map in 1755, can have nowadays an importance to assess this type of risk. Urban floods are increasingly more frequent in cities due to climate changes, being extremely important to assess their impact and to improve existing stormwater systems. The simulation of the propagation of these urban floods allows definitely to forecast the cascade flooding impacts in services and infrastructures and the times needed to restore their normal operation. These advanced numerical tools allow to add new layers of information such as orography, population density, and land occupation time for a better assessment of the potential damages caused by such events. These numerical tools also allow, nowadays, to predict natural hazards in real time and fast than real-time conditions. Definitely that the integration of such models with virtual reality tools, such as serious games, allows to train front workers to better respond to such catastrophic events. The fourth project is about urban cycling safety. The transport of people and goods inevitably implies risk. Recently, urban mobility has been evolving towards alternative solutions such as e-bikes and self-driving vehicles. Ongoing research focuses on understanding urban cycling safety, namely on how the built environments may impact the number and the severity of accidents and how people perceive and feel safe while cycling. We truly believe that combining data science tools with computer vision and machine learning techniques allows to create a framework capable of automatically and continuously assessing cycling safety. In terms of what to expect from this thematic strand in the next years, I would like to say that CERIS research allows to build the future aligned with the 2013 Agenda for the Sustainable Development Objectives and with other global policies, aiming to reduce risk and to increase resilience and safety in the natural and built environments by developing innovative and state-of-the-art tools, solutions, and approaches. CERIS research also aims to strengthen and to create new networks and partnerships at both national and international levels. We truly believe that sharing best practices and the state-of-the-art knowledge on risk and safety with the society, with the industry, and with public entities will definitely allow to minimize the potential impacts of disasters, to support sound decision-making processes and to develop risk-informed policies and programs. CERIS has demonstrated to have an excellent research tracking record and is fully available to host new talented people to tackle future challenges and to create a new perspective of risk and safety for the next generations.